Okay. So we're continuing looking at molecular shapes that start at least from a tetrahedral electron pair shape. And we looked at methane previously, which came out to be a tetrahedral molecular shape. It started with a tetrahedral electron pair shape. But now we're going to look at how we can combine nitrogen and hydrogen. Okay? And let's see, I forget where I stopped, but Alexander, how many electron dots do I put around a nitrogen? 3 electron dots? Look on your periodic table. Got your periodic table there? We're looking at all the electrons in the valence level. The valence level is the highest energy level for that atom. Here's nitrogen. There are indeed 3 electrons in the p sublevel, but these s sublevel electrons over here, represented by lithium and beryllium, they're in that second primary level too, aren't they? So when we're doing electron dots, we need all the electrons in the valence level. So how many is that? 5. Okay. So remember, when we do this, we put 1 on each of the 4 sides until we run out of electrons. In this case, we need 5. So that's the first 3, 4, and then finally I can pair up on one of the 4 sides, and it doesn't matter which one. Okay? And if I need to pair up another one, I go there and so forth. All right? Okay. Sam or Samantha, how many electron dots do I put around a hydrogen? 1. Okay? Ithbasong, how many electron dots does hydrogen want to have to be as stable as it can be? Okay, and how many electrons does nitrogen want to have to be as stable as it can be? It needs 3 more for 8. Okay, so we can share 2 electrons here, and that gives that hydrogen 2 electrons, but now this nitrogen has how many electrons available to it, Tevin?
What's the question?
How many electrons does this nitrogen now have?
7.
1, 2, 3, 4, 5, and then we shared 1 here for 6. Okay, so we need to have how many more?
1, 2.
2 more. Okay, so we need another hydrogen here to share. We can share 1 here, and we put another one here, and we can share 1 here. Okay, so we started out with electron dot formulas for these elements. And then we have taken those electron dot formulas, and by using this sharing arrangement to get hydrogen to have 2 electrons each, nitrogen to have 8 electrons each, we've found an arrangement that will get both of those to their most stable position. This is called the sharing arrangement, right? So the name of this drawing is the sharing arrangement. We started with electron dot formulas, and now we've gotten to the sharing arrangement. From the sharing arrangement, we go to the Lewis dot formula. Okay? So Rachel, what do I do to get to a Lewis dot formula? Okay, is that it? What about the set of electrons up here? You got to keep those. Okay, so that's the Lewis dot formula. And then the next thing we're going to have is a Lewis formula. And Jessica, how do I write a Lewis formula? Lines for the bonds? 3 lines? Okay, so these 3 lines right here replace the shared pairs. The 2 dots have to stay there. So there's our Lewis formula. Good. Good for both of you. Everybody's doing good so far, okay? If I keep everybody's attention here, we're doing good. All right, so now we have to go back to that same set of rules I gave you earlier. I said we're going to start with the Lewis dot formula, and that's this formula right here. Count the sets of electrons around the central atom. Sets can be 2, 4, 6. Well, I've got 1, 2, 3, 4 sets, just like I did before. And then choose the electron pair shape that gets those sets as far apart as possible. Well, the 4 sets result in a tetrahedral electron pair shape. Then 4 sets here will result in a tetrahedral electron pair shape. So we're going to start with the nitrogen in the middle. 1 set of electrons up here. 1 set of electrons over here. Now I've got, on this drawing, I put the second line there. It's okay to reverse it. Okay, it doesn't really change the shape. I'm going to make a triangle here. showing the electrons that are coming out away from the paper toward you, and then a dotted line back here showing those electrons are going back behind the paper. Okay? And so that is a tetrahedral, just like before. And since I have nothing but electron pairs around this central atom, this is how you can recognize an electron pair shape. There's nothing but electron sets around the central atom. So this is a tetrahedral electron pair shape.
Another question.
Mm-hmm.
The one on top is not shared. Are you supposed to put that line?
Yes. You have to keep all your electrons. Okay? At least at this point in time, you have to keep all the electrons. Okay? All right, so the next step then I told you was replace sets of electrons with atom symbols where electrons are shared. Do not replace lone pairs of electrons. And what I told you was redraw exactly the same drawing in pencil. Now I'm doing it in a dark marker just because it's easier for you to see on the camera when I do that. But since what I'm going to do is some changes here, I'm going to do my electron dots in pencil. Okay? So we're going to replace the sets of electrons with atom symbols where the electrons are shared. So on how many of these sets of electrons are the electrons being shared? 3 of them. So I need to erase 3 sets of electrons. Okay? 3 sets of electrons get erased. And I'm going to replace those 3 sets with the symbols for the atoms that go there, or they're being shared there. Okay? Now I still have 4 arms or legs extending around that central atom as far apart as I can get them. That's still a tetrahedral. 4 arms equally spaced, that's a tetrahedral. Okay? But this is no longer an electron pair shape. An electron pair shape has only sets of electrons around the central atom. This doesn't have only sets of electrons. This has also got both sets of electrons and atom symbols around the central atom. So this is not an electron pair shape. We've modified it. So we're going to call this the modified electron pair shape. Okay? All right, and we did not replace the electron pairs. That was the last thing we wrote in our rules a while ago. Was our original set of rules was we don't replace electron pairs. Okay, and we didn't replace the lone pairs. Okay, but here's what we have to do next. Okay, I'm going to redraw the previous drawing exactly as I did. Okay, so here's nitrogen in the center. Got a hydrogen over here. Hydrogen coming out this way. Hydrogen back here. And this lone pair of electrons up here. Alright, so we're going to add now to our rules. Okay, I gave you these rules to start with. Okay, but now we need another rule because we've reached a situation that we didn't have before. Previously, there were no set lone pairs of electrons around the central atom. But now we have a lone pair of electrons around the central atom. Okay? So our last rule is that we're going to redraw modified electron pair shapes in exactly the same way. And then erase the lone pairs. Okay? So since we didn't go straight to the molecular shape, on the last set we went straight to a molecular shape. There were no lone pairs around here. This time there's both atoms and a lone pair, so that's not a molecular shape yet. This is called the modified electron pair shape. Since we have a modified electron pair shape, we're going to redraw the same thing, erase the lone pair, including the line it's on, okay? And this gives us the correct molecular shape. Okay? All right. Now to be a tetrahedral, I have to have 4 arms equally spaced three-dimensionally around the central atom. This no longer has 4 arms equally spaced around the central atom. Okay? It has 3 arms, and they're not equally spaced. Equally spaced would be 120 degrees on a plane, but this is not 120 degrees on a plane. This has kind of been bent down a little bit into that tripod sort of shape. Does that make sense? Remember our tripod shape with the balloons? Okay? So now we have to call this something different. Okay? And if you look very carefully, you might be able to tell. If I connected the dots around here, to put all the hydrogens aligned in there, we'd have a sort of a really shallow sort of pyramid shape. You see the pyramid? It's a 3-sided pyramid. We can't call it pyramid because most pyramids have 4 sides. But we can call it trigonal pyramidal for 3 sides. Trigonal pyramidal. Okay, and this doesn't have any more electron pairs around it, so we have successfully reached the molecular shape. Previously, we reached this shape and had a molecular shape. Now we have this shape, that's the molecular shape, but it's still called the molecular shape. So it's called the trigonal pyramidal molecular shape. Okay, and that's the shape of this molecule. That's the shape of this molecule. Okay. All right. Let me finish the notes, and we'll go back to the top for just a second here. Let's go back up here and look again. I didn't put down any subscripts to show how many elements there are. Okay. How many elements am I showing in each of these structures? 3 hydrogens and 1 nitrogen. So how should I change this formula to show that? How should I change this chemical or molecular formula to show you that? NH with a subscript 3 on it. Okay? And this molecule has a name, and you need to know what it is by looking at it. This is called ammonia. You know that's called ammonia. Okay? It's one you just kind of have to memorize. NH3 is ammonia. Okay? Got all that? All right. So just to review, in the previous set, we shared 4 different sets of electrons to get to 8 for the central atom. We had 4 sets of electrons around the central atom here. All are shared, but in this case, only 3 sets were shared. This is a lone pair, and these right here, these 3 sets here, these right here are called shared pairs. Okay? Let's emphasize that I want to circle here what are called these shared pairs. Well, that's not the marker I want. These right here are all called shared pairs of electrons. Okay? This one up here, this is called a lone pair of electrons. Okay?